So namaste one and all. So today we'll be learning regarding quantization of charges. So in the previous class you came to know that we can charge a neutral body either by removing the negative charge or by adding the negative charge. So now the question is how many number of negative charges can be added or removed. So there is some rule which we need to follow while removing or adding the negative charge. So we can add or remove only integer multiple of electrons. So the charges which can be added or removed is followed according to this rule. Q is equal to plus or minus n into E, where Q is the charge. So the plus symbol indicates adding of electrons and negative symbol indicates removing of electrons, and n is the number of electrons that is added. It should always be an integer, that is 1, 2, 3, 4 or any integer number. It cannot be a fraction like 1.2, 2.4. It cannot be any fraction, and E is the electron. So electron carries a negative charge of minus 1.602 into 10 to the power of minus 19 coulomb. So this is the formula which we need to remember in order to know how many number of charge can be transmitted from one body to the other. So if you want to know the minimum number of charge that can be transferred is, so as you know, n is always an integer. The least number is n is equal to 1. So only one charge can be transmitted, that is one electron can be transmitted from one body to another. This is the minimum number of charge that can be transferred. So you can look over here, one electron is transferred from one body to other, and now again from this body it is being transferred here. So this is the minimum number of charge that can be transferred. So n is equal to 1 is the minimum number of charge that can be transferred. We cannot transfer fraction number of electrons, that is we cannot transfer half of this, that is 0.5, 1.5, that cannot be transferred. So n should always be an integer. It starts from 1. 1 is the minimum value. So now let us look at some of the questions. So here it is given that which of the following is not possible. So it indicates which of the number of charges cannot be transferred. So you already know the equation for charge transfer is Q is equal to plus or minus n into E, where n is the number of charges that can be transferred. So let us look at over here. So Q is equal to plus or minus n into E. So we need to check whether n is a fraction or an integer. If it is integer means that can be transferred. If it is not an integer, then it cannot be transferred. So now n is equal to Q by E. So let us consider the first case. Let us consider this first case. Plus, the charge is plus 3.2 into 10 to the power of minus 10 divided by, what is the charge which is present on electron? You all know that, that is 1.6 into 10 to the power of minus 19. It's actually 1.602 into 10 to the power of minus 19. So for calculation you can take it as approximately 1.6 into 10 to the power of minus 19. So while solving this, the best method is you take all the exponents on one side, so that would be easier. So you can take this as 3.2 divided by 1.6 into, so it is 10 to the power of minus 10. When this minus 19 goes above, this becomes plus 19. So that would be 3.2 divided by 1.6 into 10 to the power of plus 9. Minus 10 plus 19, that turns out to be plus 9. Now in order to solve this, 3.2 can be written as 32 by 10 and 1.6 can be written as 16 by 10. So this would be 32 by 10 divided by 16. This 10 when it goes upwards, So this gets cancelled. So into 10 to the power of 19. So that would be 16 ones are 16 twos are. So that would be 2 into 10 to the power of 19. So here n is equal to 2, which is an integer. So this is possible. So this is possible. Next, let us consider the next case. 1.6 into 10 power of minus 18. So here again let's consider second case. N is equal to q by e. So it is 1.6 into 10 to the power of minus 18 divided by, again e is how much, 1.6 into 10 to the power of minus 19. So this turns out to be, so first solve out the exponent side. So 1.6 divided by 1.6 into 10 to the power of minus 18. When minus 19 comes to the numerator, it becomes plus 19. So 1.6 1's are, so that would be 1 into 10 to the power of minus 18 plus 19 is 10 to the power of 1. So again here n is equal to 1, which is an integer. So this is also possible. Next, let us consider the third case. N is equal to q by e. So here the value of n is 64 into 10 to the power of minus 20 divided by, again 1.6 into 10 to the power of minus 19. So as I said earlier, take all the exponents on one side. 64 16 1.6 can be written as 16 by 10 into 10 to the power of minus 20. When you take this minus 19 above, this becomes plus 19. So this is 64 divided by 16. When it comes above, 10 will be multiplied with 64. That becomes 640 into 10 to the power of, this is minus 1. So that turns out to be 16 ones are 16 ones are 16 fours are 64. So that would be 40 into 10 to the power of minus 1. So that would be equal to 4. So again n is equal to 4. This is an integer. So this is also possible because n is again an integer. Now the last case, q is equal to, let us consider the last case. So here let us consider the last case. N is equal to q by e. So this is 4.5 divided by 1.6 into 10 to the power of minus 19. So this is 4.5 into 10 to the power of minus 19. So these two gets cancelled, 1.6 and 4.5. So this turns out to be 2.81. So this is turns out to be 1.6. So this turns out to be 2.81. So n is not an integer. This is what? Fraction. So this is the right option. So this is not possible. All the other three cases are possible. So the main formula which you need to remember is q is equal to plus or minus n into e. So if n is an integer, then it obeys the rule. If n is not an integer, if it's a fraction like 2.81, so it cannot be possible. So now let us consider the second question. How many electrons are there in 1 coulomb of charge? Again, you need to make use of the same formula. Again, you need to make use of the same formula. Q is equal to plus or minus n into E. So how many electrons they are asking you for? Number of electron. So present in 1 coulomb of charge. What is the charge given? Q should be equal to 1. Should be equal to what? Plus or minus n into E. So what is the number of electrons? N is equal to 1 divided by E. So what is the value of E? You know that it is 1.6 into 10 to the power of minus 19. So how can you solve this? 1. So 1.6 can be written as how much? 16 divided by 10. So into 10 to the power of, when it goes above, this becomes how much? 10 to the power of plus 19. So 10 goes above, so this becomes 10 divided by 16 into 10 to the power of 19. So this turns out to be 10 divided by 16. So if we consider 10 divided by 16, so 10 divided by 16, so this turns out to be, you take 0 point, so this is 16 6 96, 16 6 96, so that is 40 is remaining. So 16 2s are 32. So again 80 is remaining over here. So that would be, next is 16 5s are 80. So that would be 0.625 into 10 to the power of 19. So this can be written as 6.25 into 10 to the power of 18. So the correct option is 6.25 into 10 to the power of 18. So as you already know, the formula which you need to remember is Q is equal to plus or minus N into E. Let us go on to the next question. So when 10 to the power of 14 electrons are removed from a neutral metal sphere, then charge on the sphere becomes. So automatically you just need to know what is the answer for this. So here you can look, you can guess the answer. So they are saying that removing the electrons. So what happens when you are trying to remove the electrons? It becomes positively charged. So automatically this answer is eliminated. So either it should be A, C or D. So again make use of the same equation. Q is equal to, that is Q is equal to plus or minus N into E. So what they are given, how many electrons are removed? 10 to the power of 14 number of electrons are removed. So what is the value for electron? 1.6 into 10 to the power of minus 19. So that turns out to be 1.6 into 10 to the power of minus 19 plus 14. So that should be equal to 1.6 into 10 to the power of minus 5 coulombs. So this would be approximately 16 into 10 to the power of minus 6 coulombs. So the right answer is the option A, 16 microcoulombs. Now let us move on to the next question. So a body has a charge of minus 3.2 microcoulomb. The number of excess electrons it has is, again it is with respect to the same formula, Q is equal to plus or minus N into E. So they are asking a body has a charge of how much? Minus 3.2 microcoulomb. The number of electrons they are asking. So number is equal to what? N is equal to Q divided by E. So given the charge, so that is how much? 3.2 into 10 to the power of minus 6 divided by electron value is 1.6 into 10 to the power of minus 19. That turns out to be, you just take this as 32 by 10. So this can be written as 16 by 10. So into 10 to the power of minus 6, you take this minus 19 above, that becomes plus 19. So this turns out to be 32 by 10. So this 10 when it goes above into 10 divided by 16 into 10 to the power of 13. So this 10 and 10 gets cancelled. 16 ones are 16 twos are 32. So that would be 2 into 10 to the power of 13. So here n is an integer. So n is an integer. So that turns out to be 2 into 10 to the power of 13. Let us move on to the next question. When a piece of polythene is rubbed with a wool, a charge of minus 2 into 10 to the power of minus 7 is developed on the polythene. What is the amount of mass which is transferred to the polythene? Again, you need to calculate the mass of the electrons which is transmitted. So from the previous video, we came to know that when a wool is rubbed against a polythene, when wool is rubbed against polythene, so you look over here, when a piece of polythene is rubbed with a wool, a charge of minus 2 into 10 to the power of minus 7 is developed on polythene. So what happens? Electrons would be lost from wool and it would be transferred to where? Polythene. So wool becomes what? Positively charged, and polythene becomes what? Negatively charged. So this is present in the upper list in the series which I have explained in the previous video. So this is present in the bottom list. So this becomes positive and this becomes negative. So they are asking what is the amount of mass transferred. So the electrons are transferred from where? Wool to polythene, and they are asking you for how much mass is transferred. So in order to calculate how much mass is transferred, first we need to know how many electrons are transferred. So the given charge is how much? Minus 2 into 10 to the power of minus 10. From this we can get the number of electrons which is transferred. So first make use of the equation. So as you already know the equation, so Q is equal to plus or minus N into E. N is equal to Q divided by E. So Q is how much? 2 into 10 to the power of minus 7 divided by 1.6 into 10 to the power of minus 19. So again make use of same thing. 2, this can be written as how much? 16 by 10. So this is 10 to the power of minus 7. When minus 19 goes above, this becomes plus 19. So this turns out to be, so you can look over here, 2 into 10, so that would be 20 divided by 16 into 10 to the power of this would be 12. So this is 20 divided by 16. So this is 4 4s are 16, 4 5s are 20. So there is nothing but 5 by 4. So this is 4 1s are 4. So 1 is remaining. So 0.45, 4 2s are 8. Again 2 is remaining. 4 5s are 20. So that is 1.25 into 10 to the power of 12. So as you know, the number n cannot be fraction. So this is 125 into 10 to the power of minus 2 into 10 to the power of 12. So this can be written as 125 into 10 to the power of 10. So this is the number. So now n is what? It's a integer. So this is possible. So these many number of electrons are transmitted. So now you need to calculate the mass of this. So mass of this is equal to how much? Number of electrons that is transmitted, number of electrons that is transmitted into mass of the electron. So how many electrons are transmitted? 125 into 10 to the power of 10 electrons are transmitted. you know the mass of the electron right from the first class, so that would be 9.31 into 10 to the power of minus 31 kg, right? So when you multiply these two, so the answer would be 1163.75 into 10 to the power of minus 21 kg. So this is the amount of mass which is transferred to the polythene. So here what you need to know is, first we need to calculate how many number of electrons are transferred from wool to polythene. Then you know the individual mass of the electron, you multiply that by number of electrons that is transmitted. The next question is, a charge on the body is 1 nanocoulomb. A charge on the body is 1 nanocoulomb. Then how many electrons are transmitted? Then how many electrons are present on the body? So here the same question. So Q is equal to plus or minus N into E. N is equal to Q is equal to N is equal to Q divided by E. So Q is 1 into 10 to the power of minus 9 divided by, so electron is 1.60 or 1.6 into 10 to the power of minus 19. So this can be written as 1, this can be written as 16 by 10. So this 10 to the power of minus 9, when this goes here this becomes 9. So this should be 10 by 16 into 10 to the power of 10 minus, so that would be 10. So 10 by 16, so that becomes 5 by 8. So that would be 10 by 16, that becomes 0.625 into 10 to the power of 10. So this can be written as 6.25 into 10 to the power of 9. So the option is 6.25 into 10 to the power of 9. So here N is given as 6.25. It should not be a fraction, so the actual number should be 625 into 10 to the power of 7. But in the option it is given as the nearest number is 6.25 into 10 to the power of 9. So we can choose this 6.25 into 10 to the power of 9. So thank you for listening. So the quiz questions are given at the bottom description. So please solve those questions in order to better understand the concept. Thank you for listening.